The Pythagorean theorem is an if-then biconditional statement. Most of you are familiar with the then part. A squared plus b squared equals c squared. But just as important is the if part. If triangle ABC is a right triangle, then a squared plus b squared equals c squared. So in order to use the Pythagorean theorem, we have to have a right triangle. So how do we go from capital letters to lowercase letters? Let's explore our right triangle. If we look at vertex C and we follow vertex C across the triangle, we get side lowercase c. Lowercase c is the hypotenuse. If we follow vertex A across the triangle, we get lowercase a, side A, one of the legs of the right triangle. And if we follow vertex B across the triangle, we get lowercase b, the second leg in the right triangle. So how do we use the Pythagorean theorem? Well, step one, identify the hypotenuse in your triangle. In this example, our missing side is the hypotenuse. So we plug our legs into the Pythagorean theorem and we use c for our hypotenuse. 8 squared is 64 and 6 squared is 36. 64 plus 36 is 100. Now we need to solve for c. c right now is being squared. To undo squaring, we square root. The square root of 100 is 10. And the square root of c squared is just c. So c equals 10. If we look at the three sides of this triangle, we have 8, 6, and 10. Notice that all three numbers are integers and they're positive. When we have three positive integers that make the Pythagorean theorem true, those three numbers are known as a Pythagorean triple. Looking at example 2, find that right angle, follow it across the triangle. There's our hypotenuse. The missing side in this case is a leg. It doesn't matter if we call it A or B. I'm going to pick A. Plugging our values into the Pythagorean theorem, we end up with a squared plus 8 squared equals 12 squared. 8 squared is 64 and 12 squared is 144. Now again, we need to solve for our variable. We need to solve for a. So we need to undo adding 64 by subtracting 64. 144 minus 64 is 80. And again, we need to undo squared by taking the square root. So a equals the square root of 80. If you remember our previous lesson, we can't leave the square root of 80 as the square root of 80. We need to simplify it. We need to find the biggest perfect square that divides 80. In this case, the biggest perfect square that divides 80 is 16. So I'm going to rewrite 80 as 16 times 5. Now I can distribute that square root to each term, keeping the multiplication between the terms, and simplify. The square root of 16 is 4 times the square root of 5. 4 square roots of 5 is known as the exact answer. Anytime you are asked to find the exact answer, your answer should be written in simplified radical form. The exact answer also has an approximate answer. To find the approximate answer, we use our calculator. 4 times the square root of 5, approximately 8.9. 8.9 is the approximate answer. To find the approximate answer, round using your calculator. In example 3, our triangle is not drawn to scale. I always like to redraw these triangles to scale. Follow that right angle across the triangle and label the hypotenuse. Our missing side in this case is a leg. I'm going to call it B this time. Plugging our values into the Pythagorean theorem, we end up with 2 squared plus b squared equals the 3 square roots of 2 squared. But we're squaring this whole number, so we need to put that whole number in parentheses. Having these parentheses is super important. Without the parentheses, you'll end up with the wrong answer. 3 square roots of 2 is really 3 times the square root of 2. And whenever we have multiplication and an exponent, we can distribute that exponent to both terms, keeping that multiplication between the terms. Simplifying, 3 squared is 9, and the square root of 2 squared, the square root and the squared cancel each other out. I'm left with just 2. So I end up with 4 plus b squared equals 18. Solving for b, I need to subtract 4 from both sides. And then take the square root of both sides to undo squared. I'm left with b equals the square root of 14. Now I need to simplify 14, and the only two numbers that divide 14 are 2 and 7. And neither 2 nor 7 is a perfect square, so the square root of 14 is my exact answer. I can't simplify it anymore. But I can find my approximate answer. Again, type in the square root of 14 into your calculator and round. I found both the exact answer and the approximate answer.